This is Senior Algebra, Section 1.4, the real number system. In this section, we're looking at classifying numbers on a graph, identifying solutions of equations, and finding additive, inverse, and absolute values. So we get by a few definitions here. If you haven't, pause the video and take a second, write them down, and then we'll continue on. So taking a look, when we think about numbers here, I want you to think back to when you were little. When you started counting, you probably started counting 1, 2, 3, 4. So if we look down, about 2/3 of the way down, we have what are known as natural numbers. Those are kind of the numbers that we think about when you began. 1, 2, 3, 4, 5, etc. Then we have whole numbers. Whole numbers are all those natural numbers, 1, 2, 3, 4, 5, etc. And 0. We have integers, and integers include 0, 1, 2, 3, 4, all those, and negatives. So we have those. But we know that there are other numbers as well, right? Not just whole numbers or natural numbers or integers. We have other numbers in there. So what about 1/2? What about 3/8? What about pi? All these other numbers here. Well, we can kind of describe these as rational numbers or irrational numbers. A rational number is a number that can be written as a quotient of two integers. So basically, like we said, 1/2, 3/4, those would all be considered rational because it has a quotient dividing two integers. 1/2, 3/4, negative 5/8 would all be considered rational numbers. When we look at in terms of a decimal, 1/2 is 0.5. 3/4, that's 0.75. Anything that is known as a terminating decimal, terminator, it ends. Okay, so it stops, is considered rational. So if I had 0.68, well, I could write that as a fraction. 68 over 100, that would make it rational. So anything that ends, that terminates, I could write it as a rational number. It is a rational number. Now, what about 1/3? Well, 1/3, if I was to figure out the decimal, that's 0.3 repeating. That's the line over there, it means repeating. So 1/3, well, that goes on forever, 0.33333. In that situation, we know 1/3 is rational. Okay. As the decimal approximation, the 0.3 repeating, okay, that means that it goes on forever with a pattern. Okay. So anything that would go on forever with a pattern is a rational number. 0.12121212, 0.44444444, all those would be considered rational numbers because they go on forever with a pattern. They can be written as a quotient of two integers. You may not know what they are especially, but they can be written as 0.1583333333. That would be an example of it. An irrational number would be all those numbers that cannot be written. Our most famous is pi, 3.14159. It goes on forever without a pattern. Other ones that you may see, quite a few radicals, like radical 2 or square root of 2 over 7. The square root of 2, that is not an integer, therefore it would not be considered rational. Even though it's a quotient, it's not the quotient of two integers. If you were to do the square root of 2 in your calculator, you get 1.41, etc. It goes on forever without a pattern. After that, we have rational and irrational. Those together make up the real numbers. We also have what are known as imaginary numbers. Now, we don't talk about imaginary numbers quite as much in this section, and we don't do a lot with solving them. We will a little bit later in the year, but not a ton. What we have to remember about imaginary numbers is that they are actually imaginary. It was a derogatory term when it was first introduced. back in the 1500s, I believe. I 5i. I is the square root of negative 1. When we look at this, taking the square root of a negative, we really can't do. Okay? But when we bring along imaginary numbers, that's when we can start to do it. Again, not something we need to worry about a ton right now. The next thing, the additive inverse. Okay? Now, this is not exactly part of the real number system, but it is an important aspect. When we look at additive inverse, it's the number, okay, that is kind of the opposite, if you want to think about it that way. The same distance away from 0, okay, but on the opposite side. So 5, negative 5. Negative 7, the additive inverse is 7. 2/3, the additive inverse would be negative 2/3. Whenever I add two numbers together, 5 plus negative 5, the number plus its additive inverse, I will always get 0. And that's an important property in algebra that you do see quite a bit. The next one, absolute value. I know we've seen this before. It's the distance between 0 and the number on a number line. How far is 0 away, or how far is a number away from 0? So if I look at 5 and 0, how far is 5 away from 0? It is a distance of 5. But if I look at negative 5, how far is negative 5 from 0? Well, it's the same thing. It is a distance of 5. Since we are talking about distance, it will never be negative. We say that the absolute value is non-negative. So the absolute value of negative 5, the distance negative 5 from 0 is 5. The absolute value of 5 is 5. 5 is that far away from 0. So that's what we think of. We think of distance away from 0. On these next ones, if we take a look, we have two representations of the real number system. If we look at the bottom one has complex broken up into two types. Real, those are the ones that we have talked about, we'll talk about quite a bit. Rational, irrational, that type of stuff. And imaginary. Imaginary, again, square roots of negative numbers there. But real can be rational, irrational. And then rational numbers, it could be an integer, could be a whole number, could be a natural number. It depends on that. If you look above, you've seen those Venn diagrams as well. They have some examples of real numbers, rational numbers, integers, whole numbers, and naturals. Notice, if a number is natural, like 2, it would also be considered a whole number, or an integer, and a rational number, and a real number. Okay? If a number is irrational, like pi or square root of 2 there, it would not be rational. It can't be a natural number. So in example 1, we're going to look at the number there, we're going to classify it, and we're going to graph it on a number line. So if I look at negative 3, okay, first thing I look at, is it real or imaginary? Since it is not the square root of a negative, it is real. And then I look, is it rational or irrational? Could I write this as a fraction? Okay, could I write it as the quotient of two integers? Negative 3 over 1? Yep, so that's rational. The next thing, okay, is it any of those classifications? Is it an integer? Negative 3, yes. Is it a whole number? Nope. Whole numbers are 0, 1, 2, 3, 4. So it would be real, rational, and an integer. 4.3, real or imaginary? It's real. Okay. When I think about 4.3, okay, I think, okay, could I make that a fraction? Yeah, 43 over 10, I could. So that would be rational. In C, it is real, not the square root of a negative, but when I have the square root of 2, that's not an integer, so it would be considered irrational. If it's irrational, there's nothing else I can do. It can't be a whole number, can't be natural, it cannot be an integer. D, we have pi. Pi is a real number, it's not the square root of a negative. It is real and it is irrational. We've already looked at that a little bit. E, now this is an interesting one, square root of 20.25. First thing, what is the square root of 20.25? 4.5. Well, that is real. It's not the square root of a negative. And at this point, rational, irrational. Well, I can write that as a fraction, or it terminates 4.5, so it would be considered rational. In F, square root of 5. Well, that's 2.23. Kind of goes on without a pattern. Okay, it is real, first thing, but it would be considered irrational. It goes on forever without a pattern. I have 0. 0 is a real number. It is rational. I could write that as a fraction, 0 over 1. And then it is an integer. Integer is -3, -2, and 1, 0, 1, 2, 3, and it is a whole number. It is not a natural number. That's the only thing it isn't. -7/3, real. Definitely. Rational, irrational, that's rational, written as a fraction, 2 integers. At that point, there's nothing else. It's not an integer, not a whole number, not a natural number. So 3 is real. It's rational. I can write it. It is an integer and a whole number and also a natural number. That's the last thing that I would look at. Okay, 3, yeah, 1, 2, 3, 4. 1.3, remember the line above it means it repeats, goes on forever with a pattern. If I wanted to, I could write that as a fraction. If you know what 0.3 is, that's 1/3. So 1 and 1/3, that's like 4/3. It is real, not the square root of a negative. It is rational because it is 4 over 3. Okay? It's nothing else simply because it's not an integer. In K, square root of a negative, that's imaginary. Okay? It can't be real, can't be anything else. If it's imaginary, can't be real, can't be rational, can't be irrational, can't be a natural number, a whole number, or an integer. So looking at this, we're going to plot these points. A, -3. B, 4.3, that's going to be between 4 and 3. C, the square root of 2, that's 1.41 over 5, that's about 0.28. So that's between 0 and 1, about a quarter of the way between. Again, you're not going to be very precise on this. You want to be about, halfway on a half. If it's less than a half, be to the left, right of the half, etc. For D, pi, 3.14. E, 4.5, about right in the middle there. F, 2.23. Okay, so that's going to be 2 1/4, something around there, pretty close. 0, we should know where that is. That's our G. H, -7/3. That's -2 and 1/3. So -2 and 1/3 over, should probably be a little bit more to the left. Yeah, that's a little bit better there. 3, I hope we know where that is. J, 4/3 or 1 and 1/3. And the last one, K, we can't do. That's the real numbers only. We can't graph it. So the last example here, example 2. Actually, I think there's 3, sorry. So we simplify these. The absolute value of -6, how far is -6 away from 0? 6. In B, absolute value of 5 is 5, the distance away from 0. In C, the first thing I'm going to do is I'm going to do what's inside. The absolute value of 4 is 4. In D, absolute value of -3 is 3 there. So I do what's inside first, then I would take the absolute value. I cannot split it up or do anything like that. The last one, that's example 2 again. It should be example 3. Absolute value of -6 is just 6. Yeah, just 6 there. 6 is greater than -10? Yes, that's true. In B, the absolute value of -5 is 5. 5 is less than 0. Is that true or false? That's false. And then the last one here. We have the negative here. It's a little tricky here. It really means -1. And the absolute value of -12 is 12. So it's really -1 times 12 greater than greater than 3. So I have -12 is greater than 3. Is that true? No, that's false. Okay. Sorry about getting the video on late. Good luck on this lesson.